Good morning, all of you. I'm very honored to be invited to present some of my work we did at this British Dragonfly Society. I'm really pleased to talk about the citizen science project we did in cooperation with many volunteers. But before, let me see. Goes always different than you think, right? So before I go into the content, I think I need to explain a little bit about the context, and that will be about myself, about how the water quality monitoring is done in the Netherlands, and a little bit about the citizen science project. And then I will dive in the really topic, the dragon and the damselflies. And I think this context is needed to understand why we did as we did it. So I hope that it is more quickly for you to understand what the results are and how you can interpret them. So I'm from this part of the Netherlands. So near the pink dot, there we have a nice university, which is called Wageningen University. I work there as a lecturer and as a researcher. And my main topic is aquatic ecology. I deal with the macroinvertebrates, so the small animals that live in the water, but also at the water plants, frequently related to streams and ditches, so the smaller sized ecosystems. And my hobby is multiple stress, so many different factors are affecting your ecosystem and who is contributing most or less. So that's a kind of a puzzle I like to solve. I'm also associated to Globe. Globe was founded by Al Gore in the 1990s with the idea that scientists help secondary school pupils in doing science. And those secondary school children deliver their observations back to the scientists so that they work nicely and together and cooperate. So I'm the so-called Dutch water scientist in this organization. And you will see later on why I mentioned this. My connection with the Odonata started because I was involved in all those creatures you can see here. Insects, larvae of insects, but also non-insects. So if you are monitoring the aquatic environment, you come across many different forms, the beautiful ones, like the damselfly and the dragonflies. But as part of the whole community, of course. And I think insects are really, really interesting and important because they are the connection, the bridge between the aquatic environment and the terrestrial environment. So if you want to have those nice creatures flying around or prowling around in the water system, both your environment in the terrestrial domain as well as in the aquatic domain should be of a good quality. So it are perfect insects, I think, to animals that really show how our world is connected. A little bit of background regarding the management of the water systems in the Netherlands. So if you start from aquatic point of view towards the Odonata, and then the management of water systems is also important, I think. Management is, I think, is the same as in Scotland, a legal task for regional and national water authorities. Even as a small country in the Netherlands, we have 21 regional authorities and one national authority. They should take care of that there is enough water when it is a dry season, or that the water is discharged fast enough so that we have our dry feet when it's really rainy, like today in the Netherlands. I understood that parts of Scotland or England are also a little bit wet today. And on the other hand, the water quality is also monitored by the water authorities. And on a yearly basis, they investigate the quality around 1,000 samples per year, including looking at your macroinvertebrates, but also the water plants, the fish, algae, and some environmental conditions. But then maybe the question becomes, what kind of waters do we have in the Netherlands? And maybe you are not aware what you can find here. So it will be a small tour across the Netherlands. So on this panel, you will see where we are. And in this part, some pictures will appear, and I will tell a little bit around it. So like in many cities worldwide, we have many canals, water systems in the urban environment, with or without a fontaine, to make sure that the oxygen condition in the water is good enough. In the middle here, you can see the city of Amsterdam. Schiphol is over there. The harbor. We have the big lakes, at least in our opinion, they are big. Managed by the National Water Authority. A little bit to the south, we have, I think, what is more in common in your country, elevation in the landscape with the faster flowing streams like these. And we have one major river, which is the Meuse River, which comes from France and flows in this direction towards the North Sea. Also, in the lower parts, these parts are below sea level in the Netherlands. This one just at the sea level. We have many of those ditches, all connected with each other, some not. Around 300,000 km of ditches we have in the Netherlands. You see sometimes the peaty area or clayish, depends a little bit where you are. Sometimes the peat is being dug quite a lot, and small ponds or lakes up here. More in the higher lands, we have less of water. We have heather, a nice part, but for aquatic ecologists, you cannot find that much over there. Then around the coast, where there were no dunes, so here we have a row of dunes, but not in these parts. It's flat. The sea has had an influence. It's also from this part of the Netherlands. Waterways dug out by us, by the people. In the center, we have the big rivers, like so the big river, the floodplain, lakes in the floodplain, and the River Rhine and the River Meuse. I think you will know them. And in the end, we do have some smaller lowland streams, like these, in a little bit higher elements. So, but not here. Here it's much higher. And I think this shows that we do have a quite variety of landscapes, but also a variety in water systems. And this will come back later on in my talk, I think, and then we can see the connection. So a little bit of background on the citizen science project. So in 2018, so I joined the Globa in the Netherlands in 2015. There was some program for looking in the water with the animals. At that time, they didn't know what to do with all the data. So I have a history in making water quality assessment systems. So with that material that was present there, we decided we make a small, nice tool with which you can identify the water quality based on the microinvertebrates you can find. So, and in 2018, we launched a web application. And this is our logo, and you see nicely that in this logo, we do have the damselflies incorporated. The web application you can enter by waterdiertjes.nl. This means small water animals. And we developed that because we were thinking, okay, if those secondary school pupils are inventing or investigating their waters in the neighborhood, it would be really nice if they can exchange their findings all over the country. So if you're in the north and the south, it doesn't matter where you are, but if you can communicate among each other through a platform, that would be very interesting. That was at least our idea. So we started with that, but then we were thinking, yeah, if we make it for secondary school children, why not for everybody? So in the end, we made a simple tool. Everybody may contribute. You go to a nearby water system, collect the water animals, identify them to a relatively simple level. It's the name trail from the FSC we used initially. Then you can send in your catches to waterdiertjes.nl, and what we give back as a reward is a water quality score based on the animals you found, and it will be visible on the map. So we have a nice map of the Netherlands, all colored from red to green. So if you send in your contribution, you can look it up on the website again, click on the dot and see what you have found. So all other people can find it also back. And we had as main initiative to raise awareness about water quality and the beautiful life underwater. Okay. Having such a system, so I now go more into the depth of the content of the story. So if there are many professionals looking at the water quality, monitoring the water quality, and you also have the volunteers, is there any additional value of those volunteers? I think that is a fair question you can pose, because if it's organized that well, what can we contribute as volunteers? So what we did was making a comparison between data we had from the professionals and from the volunteers. And here on the graph, you see a distance on the horizontal axis, and on the y-axis, a frequency. So we were finding out what is the closest nearby point from the professional if you start from the volunteers. So it means that within 4 km, you find always a point where a professional has been monitoring the water quality. And you also see that the majority is within 1 km. So within 1,000 meters, there will be always a location where the water professionals have sampled. With one of the previous slides, you also saw all those dense networks of the ditches. Even a distance of 20 meters may mean in the Netherlands that you are really sampling a different water system, because there might be a bridge in between, or a road in between, sorry. So different polders. So even if they are quite close to each other, you're not very sure that it is the same water system. So that's one thing. Also, if you look at the timing of the sampling, so you see the different years we had in this analysis, the different months. You see the professionals in blue sample mostly in April and May. While the volunteers, they await a little bit better weather, I think. They like to have the sun shining. They go in May and June and July. And in 2020, when there was a lockdown, we could greatly see that effect of, if you're not allowed to go to work or to school, you do other things. And one of the things can be having a look at the water quality in waters nearby. So the timing is also a little bit different. And then what struck me most is that professionals, they are really interested in the streams, whereas the volunteers more frequently sample ditches and parts in the urban environment. So I said before, we have 300,000 km of ditches and 60,000 km of streams. And the attention of the water, the professionals is more towards the streams than towards the standing waters. And I think that is really interesting to show. If you're interested, you can read this in this paper. But the final conclusion is, I think, that the volunteers really visit other locations than the professionals. So there is an added value of this kind of citizen science work. And I think that's really cool. Also for the volunteers, that they really can contribute in making visible what water quality is in the Netherlands. Then a little bit later, a few years later, we were thinking, maybe we should do something else. And we are running the program now for several years, but can we organize it in such a way that people are doing field in parts that we are interested in? So we are all volunteers, so we are not paid for this, or hardly paid for it. It's all what we can do. So we don't have much money for campaigns. So the only thing we can do is putting something on our website. We are interested in, say, your garden pond, how's the quality, and then hope and see what will come. So in 21, we indeed had the garden pond as one of the topics. We were really interested because the professionals are not going to the garden ponds because they have no right to sample your pond. And it appeared that quite some people were monitoring the animal life in their ponds. So we wrote a small paper about this, but for me, the most important conclusion is not this paper, but that if you put on your website the idea that maybe you can sample this, that people are really interested in following you and doing so. So specific campaigns might work. And that brings me to the really study on the dragon and the damselflies. So in 2023, we focused on the odonata. And you may question why. Again, amazing insect, in my view, connecting the interface between water and land, very important. If you check the literature, frequently there are indicators for the water quality or the environmental quality. And if it's about the citizen science project, it's handy if they are easy to recognize. And especially we look at the suborder level, so the Zygopteran, Anisopteran, so the dragonflies and the damselflies. We do not go to the species level. And what we did was asking the volunteers to see what do you see for adults while you're doing the aquatic inquiry. So you sample your water body and have a check around you. What kind of dragonflies do you see around? Our focus was, maybe one of the questions, the first, if you see an adult flying, does it tell you something about the presence of the juveniles in the water system you are looking at? So that is the relationship between the adults and the juveniles in the water system. Now the question is, of course, but if you do those observations, can you link the presence, absence to easy to register or measure environmental variables? So can we get more information about that? And finally, I'm also interested in water quality issues. So how good are the different stages as indicators for good water quality conditions? That were our three main questions we had. And we asked the people to do so. So we had in 2023, roughly 560 locations sampled, 40 animals. In more than 360 cases, there was also information on the adult odonata. That can be either presence or the absence. So also we looked at it, but we haven't seen them. And we had simple variables where we looked at, so is it a running or standing water? What is the shape of your water system? Categories of the depth and the size of the system, land use type. We also looked at and asked for submerged and floating, also riparian vegetation, fish, and we had the biological water quality. A little bit of statistics, so if you don't are not really interested in, then it will be short, but to compare the counts of the adults and the juveniles, we use this kinds of test, the chi-square test. We also did some regression models, specifically called the generalized linear models, but we wanted to relate the presence to the environmental conditions. That's one part. And we also relate the presence to the biological water quality following these models. The first question, what's the relation between the adults and the juveniles? Here we have the counts on the y-axis. Here it is the presence of the adults and the larvae. Adults present, absent. I blocked this one a little bit because my focus will be on the presence of the adults and the relationship with the larvae. And here we do have it for the damselflies. So what you do see is that the damselflies, if you see an adult, you see in more than 55% of the cases also a larvae in that water system. If you see an adult dragonfly, the chance of finding a larvae will be much lower. So roughly 25% chance of getting then a larvae. So if you look at the counts, adult dragonflies, worse predictors of their juveniles than adult damselflies. That's what the conclusion we drew from this. Then what is the relationship within the different groups on the environmental variables? First, I explained the general setup. This part deals with the adult dragonflies. This part deals with the adult damselflies. Here we have the part of the larvae, the dragonflies, and the damselflies. The graphs have a red panel and a green panel and a line in the middle. The middle line is the reference. If you're on the right-hand side, it means it has a positive effect on the presence of that group. If it's on the left-hand side in the red box, it gives you a negative influence. So in this case, we talk about the submerged vegetation for the adults of the dragonfly. If there is less than 5% coverage, or on the 0 score. If it's higher, then you move to the right, you're in the green area. That means that the presence of submerged vegetation is positive for seeing an adult dragonfly. The dot is the average. This is the range, and the asterisk means that it is, according to the statistical test, significant. So what we see that for the dragonflies, the only thing we found was the presence of the submerged vegetation being significant. For the damselflies, the adults, we found that the submerged vegetation, but also floating vegetation, had elements influencing the presence of these damselflies. So you see that all categories of the levels of the vegetation give a positive effect on the presence, but there are only 2 that are really significant. If we now go to the larvae, we don't see any vegetation. So vegetation in the water seems to have no influence on the presence of the larvae of the dragon and the damselflies. What we do see is that the shape of the system, so if it's a pond-like thing or a stream, does have an effect, with a negative effect for ponds, lake-like systems in comparison to the ditches and the streams. And furthermore, if you compare the standing waters with the running waters, you see even more larvae of the dragonflies in the running waters. For the damselflies, we found that there is a positive relation with depth. So in the very shallow parts, the abundance is lower, or the presence is lower in comparison to the somewhat deeper parts. So increasing depth gives a higher chance of finding larvae of the damselfly. And again, running water has a positive effect on the presence of these larvae. So, general conclusion, vegetation is only important for the adults, and found that surprising, but I also found surprising that we found no effect of fish presence. So I was thinking fish is a known predator on the larvae of the Odonata, but we could not find it here. Then we go to the relationship with the biological water quality, which was defined on the presence of all the other animals we found. Interestingly, the adults showed no correlation with the water quality. So, and that is on the suborder level, so the damselfly and the dragonflies. If we go to the larvae, it's the same as just before, but since all is in the right-hand side, I made only the green panel. This is the very lowest quality, and on top you see the good quality, low quality, high quality. The presence of the larvae from the dragonflies is associated with the highest water qualities, and for the damselfly it's a little bit lower. I found this a little bit strange, but okay, it is what it was in our data set. So the conclusion, dragonfly are associated with higher quality classes than the damselflies, more or less. Then I have a few points for the discussion. I think I have still 4 minutes left, so we will do that. If you deal with citizen science, it's always the question of what is the quality of the data? How reliable is that data? You cannot trust the volunteers. On the other hand, you find in science also papers where seems to be very difficult to repeat what scientists did. But there is for sure a bias in the sampling effort. Some are sampling, say, in 20, 30 seconds, others are moving around in the water system for a few minutes. So that really can generate differences in the numbers you get. Also differences in identification, although this is not the case for the odonata, I would say. What I checked was that I checked the ratio between the dragonfly and the damselfly larvae, which appeared to be 0.4 in our data set. And I checked that also with the professionals, and they came to a 0.41 value. So that gives for me the idea that representative, so collecting the larvae of the odonata is quite well done by the volunteers, and that has to do, I think, with the large size. So frequently the odonata larvae are large, and volunteers are biased towards the larger individuals, so they see them easily, and it is not so difficult to identify them. So that's one part. If we look at the results, I said adult damselflies are better related to their larvae, but another interesting thing from professional data set I found was that if you see from all those samples they took, they found roughly 6 dragonfly larvae per sample and 21 damselfly larvae. So by chance, to get a damselfly larva is always higher than a dragonfly larva, just because there are more in the environment. So that's to take into account also. Another element, of course, is dragonflies. They really fly larger distances than damselflies. So the damselfly are more sedentary, whereas a dragonfly, I think can fly a few kilometers during the day. So that's quite some distance in comparison to the damselfly. So that you see a damselfly or a dragonfly when you are sampling is maybe not saying that much towards the water system you're there, because they can fly larger distances. Then another point of discussion is we had important vegetation was important for both the dragon and the damselflies, adults, but not for the juveniles. And we know that the adult damselfly needs the aquatic vegetation to deposit their eggs. So that's a good reason to find it. And maybe we saw that the dragonflies avoided the low vegetation. That could be interpreted as maybe they see that as an indication of minimizing predation risk. So they know that fish eat their larvae, but also that if vegetation is present, then fish has difficulties. So it offers them places to shelter. As said before, fish has been reported as a predator of odonata larvae. But maybe the way we registered the fish presence through the volunteers is not completely okay. So maybe we should change that a little bit. Then finally, the indicator qualities. Indicators of environmental quality and some of the water quality if you look at the adults, but this is not supported by our study. So it could be that that is really species specific, and that if you go to the suborder level, it's not good enough. But we though saw that the dragonfly larvae were indicator of a better quality than the damselflies. And I think that is due to the longer lifespan and maybe carryover effects. That brings me to the conclusions. Quickly, the first one is that damselfly coincides better with the juveniles than the dragonflies. Vegetation is overall very important for their adults. Adults are not a very good indicator of water quality, and the dragonfly larvae do so and do better than the damselfly larvae. And if you want to look it back, you can read it in the publication listed over there. That brings me to the end. I would like to thank all the volunteers that contributed. Without them, I could not have shown this to you. And I thank you for your attention. And I think there is no time for questions, so that will be later in the Q&A session. Thank you.